Joe Rogan has finally revealed the shocking image that the Webb telescope captured, finally showing what Oumuamua looks like. In 2017, astronomers spotted something unusual passing through our solar system. It was Oumuamua, the first known interstellar object to visit us. But what do the images of Oumuamua reveal about its true nature? And could these pictures change everything we know about the universe? Let's dive into the details and find out what this interstellar visitor can tell us about the universe beyond our solar system. Back in 2017, the astronomy world got a massive surprise. The Pan-STARRS 1 telescope in Hawaii, which is always on the lookout for strange events happening around the universe, spotted something totally out of the ordinary. It was Oumuamua, the first ever observed interstellar object to pay our solar system a visit. The discovery of Oumuamua set off many questions among scientists and pretty much everyone who heard about it. People were fascinated for obvious reasons. Here was tangible proof that stuff from way beyond our solar system could come wandering in. And now, the James Webb Space Telescope has finally captured a shocking image of this object that has revealed its true nature. But Oumuamua wasn't intriguing because of where it came from. This object had some pretty odd features that set it apart from the usual comets and asteroids scientists were used to seeing. For starters, its shape was something else. Most space rocks we encounter are somewhat roundish or irregular, but Oumuamua was long and skinny. It was a rock stretching out as long as a football field but with a fraction of the width. Then there's its path through space. Oumuamua zipped into our solar system at a speed and angle that made it clear it wasn't from around here. It was moving so fast that it was just passing through. It did not get caught up in orbiting the sun like most space debris that comes our way. And perhaps one of the most puzzling things about Oumuamua was its lack of a cometary tail. Most comets have iconic tails of gas and dust that stream out behind them. Oumuamua didn't have one of those. Despite getting pretty close to the sun, where you'd expect a comet to start spewing out material, Oumuamua stayed tailless. This was a big clue that it wasn't your typical comet or asteroid. Oumuamua's arrival was like nothing we'd ever seen before. Its interstellar origin, unusual shape, and unexpected behavior had everyone from professional astronomers to casual space fans asking questions. What was Oumuamua, really? Where did it come from, and what could it tell us about the universe beyond our solar system? So how did the James Webb Space Telescope spot this strange object? The James Webb Space Telescope is a crucial piece of technology in space exploration. Named after James E. Webb, the pioneering NASA administrator who played a crucial role in the Apollo missions, the telescope represents the next leap forward in space observatories. Its journey from conception to the final frontier is a tale of collaboration, innovation, and the unyielding human spirit. The idea for the James Webb Space Telescope began taking shape in the late 1990s as a successor to the Hubble Space Telescope, with the ambition of looking deeper into the universe than ever before. Developed through an international collaboration led by NASA, with significant contributions from the European Space Agency and the Canadian Space Agency, the telescope was designed to answer fundamental questions about the universe's earliest stars and galaxies, the formation of solar systems, and the potential for life elsewhere. At the heart of the telescope's capabilities is its suite of advanced instruments and a massive 6.5-meter primary mirror, composed of 18 hexagonal segments made from gold-coated beryllium. This mirror is significantly larger than Hubble's, allowing the telescope to collect more light and observe objects in far greater detail. The telescope's design enables it to observe in the infrared spectrum, which is essential for looking back in time to see the first galaxies that formed after the Big Bang, as their light has been stretched into infrared wavelengths by the expanding universe. The telescope is equipped with 4 main instruments, which are the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor/near-infrared imager and slitless spectrograph. Each instrument plays a unique role, from capturing detailed images to analyzing the chemical composition of celestial objects. One of the James Webb Space Telescope's most groundbreaking features is its ability to observe the atmospheres of exoplanets, potentially identifying signs of habitability or even life. By analyzing the light from stars as it passes through an exoplanet's atmosphere, the telescope can detect chemical signatures that may indicate the presence of water vapor, carbon dioxide, methane, and other key molecules. The telescope's path to the stars was not without its challenges, including technical hurdles, budget overruns, and delays. However, after years of meticulous planning, construction, and testing, the telescope was finally launched on December 25, 2021, aboard an Ariane 5 rocket from French Guiana. The telescope then embarked on a month-long journey to its operational orbit at the second Lagrange point, about 1.5 million kilometers from Earth, where it remains shielded from the sun's heat and light, providing an unobstructed view of the universe. Since its deployment, it has begun to fulfill its promise, delivering breathtaking images and data that are reshaping our understanding of the universe. Its early achievements include capturing the most detailed views yet of distant galaxies, observing the atmospheres of exoplanets, and looking into dense cosmic dust clouds where new stars and planetary systems are being born. When Oumuamua came onto the scene, the James Webb Space Telescope became our best bet for getting a closer look. Its suite of instruments and unparalleled sensitivity to infrared light meant that it could capture details about Oumuamua's shape, size, and possibly even its composition that other telescopes couldn't. The build-up to the telescope's observation of Oumuamua was a major space event. Scientists and space enthusiasts alike were on the edge of their seats, waiting to see what the telescope would reveal. The anticipation was about the broader implications. This was our chance to gain insights that could apply to others like it, perhaps even shedding light on the building blocks of other solar systems. It was a test of our ability to observe and understand phenomena from other star systems, using the most advanced tools at our disposal. The insights expected from this observation had the potential to open up new frontiers in our understanding of the universe, making it a pivotal moment in the field of astronomy. Why does this object cause so much fascination? Since Oumuamua zipped through our solar system, it's been the star of quite a few scientific head-scratchers. One of the biggest debates is its shape. Initially, some thought it looked like a cigar, long and skinny. But then, a new camp started arguing that Oumuamua might actually be more pancake-like, flat and wide. This goes to the heart of understanding Oumuamua's journey through space and what forces it might have encountered along the way. Diving deeper, scientists have had all sorts of theories about what Oumuamua is made of and where it came from. One of the theories is the nitrogen ice hypothesis. According to this, Oumuamua is a chunk of nitrogen ice that broke off from a Pluto-like world in a distant star system. If true, this would explain its unusual acceleration as it passed by the sun and tell us a bit about the neighborhood it came from. One of the most talked about theories is the idea that Oumuamua could be an artificial object, perhaps a probe sent by an advanced alien civilization. This speculation is fueled by its unusual acceleration as it passed through our solar system, which some scientists argue could be indicative of a light sail, a thin, wide surface propelled by solar radiation. While this theory leans more towards science fiction and lacks concrete evidence, it shows the huge impact Oumuamua has had on our imagination and our desire to find connections to other intelligent life in the universe. Another compelling hypothesis suggests that Oumuamua might be a fragment from a disrupted planet or a planetary building block, known as a planetesimal, from another star system. This theory says that Oumuamua could be a piece of a larger celestial body that was torn apart by gravitational forces, possibly during a close encounter with a star or a giant planet. Such an event could explain its elongated shape and unusual trajectory, as well as provide insights into the violent processes that can occur in young solar systems. While the true nature of Oumuamua may remain elusive, each theory contributes to a broader understanding of the processes at play in our universe. But with something as unusual as Oumuamua, it's easy to let our imaginations run wild. Sure, Oumuamua is weird, but jumping straight to extraterrestrial explanations without solid evidence isn't how science works. So, as we piece together the puzzle that is Oumuamua, it's crucial to keep an open mind but also stay grounded. The truth about this interstellar visitor is likely to be strange enough without needing to venture into the world of science fiction. So what did the recent image captured by the telescope reveal that has had the science world so excited? When the James Webb Space Telescope turned its gaze toward Oumuamua, the anticipation was palpable. It was the first time we were getting a real, up-close look at an interstellar object that had wandered into our solar system. The image we got was groundbreaking. For the first time, we saw Oumuamua as a distinct object with features and characteristics. The level of detail was unlike anything we could have achieved with previous telescopes. This was our first real glimpse of something from another star system, and it was as thrilling as it sounds. This image, and the data that came with it, had the potential to either back up or destroy a lot of the theories that had been going around about Oumuamua. Was it the cigar-shaped rock some had imagined? Or was it more pancake-like, as others had speculated? The initial interpretations of the image started to give us some answers. Scientists began discussing the details, comparing them to the various models and predictions that had been made. For some theories, the image was a confirmation. For others, it was back to the drawing board. What was clear was that Oumuamua was continuing to surprise us. Its shape, which appeared more complex than many had anticipated, challenged our assumptions about what interstellar objects could look like. And as for its composition, the data suggested that Oumuamua might indeed be something quite unusual, not just a simple rock or ice ball. This revelation marked the beginning of a new era in our study of interstellar objects. With this level of detail and clarity, we could start to piece together more accurate stories of these wanderers. Oumuamua's visit, and the data we've gathered from it, could help us understand and provide insights into the processes at work in other star systems. The telescope's first image of Oumuamua was a key that started unlocking answers to some of our questions about the universe. And as we continue to study this image and gather more data, we're likely to find that Oumuamua has even more secrets to reveal. So let's break down what this all means for our understanding of interstellar objects and their place in the grand scheme of things. First off, getting a clear shot of Oumuamua with the telescope is a big deal because it's our first real look at something from outside our solar system. This has given us a rare chance to study material from another part of the galaxy. This is key because every little detail we learn about Oumuamua can tell us something about where it came from and how it ended up here. But the implications go way beyond just one object. By studying Oumuamua, we're getting clues about the processes at work in other star systems. For example, if Oumuamua really is a chunk of nitrogen ice, as some theories suggest, it could mean that there are Pluto-like planets or objects in other star systems going through similar processes as in our own solar system. And here's another thing. Oumuamua's visit suggests that interstellar objects might be passing through our solar system more often than we thought. This has huge implications for how we think about our place in the universe. Each of these interstellar visitors has the potential to teach us something new about the universe. Thus, the telescope's observations of Oumuamua are helping us connect the dots between our own solar system and the wider universe. We're starting to see how the movement of interstellar objects like Oumuamua could be a common thread linking different star systems together. So, as we continue to study Oumuamua and await the next space visitor, we're armed with better tools and a growing knowledge base. But what could the continued study of objects like Oumuamua reveal? For starters, we might uncover more about the building blocks of planet formation and the common or rare materials in other parts of the galaxy. We could learn about the forces and events that send these objects on their interstellar voyages, from gravitational nudges to massive collisions. The biggest question this object has created is about life beyond Earth. While interstellar objects like Oumuamua might not be harboring alien life, the materials they carry and the environments they've encountered could provide crucial context for understanding where and how life could exist in the universe. As we look to the future, the prospects for interstellar research are boundless. With each new discovery, we're expanding our understanding of the world and our place within it. The next Oumuamua-like object could be just around the corner, ready to challenge our assumptions and ignite our curiosity once again. While Oumuamua's flyby was breaking news, it's not the only one of its kind that's had scientists excited. The universe is vast and full of mysteries, and every now and then, it sends something our way that reminds us just how much we've yet to learn. One mysterious object much like Oumuamua is 2I/Borisov. In 2019, an amateur astronomer named Gennady Borisov spotted something special, the 2I/Borisov, the second interstellar object we've ever seen entering our solar system. What's interesting about 2I/Borisov is that it clearly behaved like a comet, complete with a glowing head, or coma, and a tail made of gas and dust. This was quite different from Oumuamua, the first interstellar visitor, which didn't have these typical comet features. The arrival of 2I/Borisov was a big deal for scientists because it gave them a chance to study a comet from another star system up close for the first time. By looking at 2I/Borisov, astronomers hope to learn more about what comets from other parts of the galaxy are made of and how they might be similar or different from the comets in our own solar system. When scientists studied 2I/Borisov, they found some familiar things. For example, they detected cyanogen, a chemical that's also found in many comets that come from our solar system. They also found water and carbon monoxide in 2I/Borisov's coma. These discoveries suggested that, in some ways, 2I/Borisov wasn't so different from our local comets, which hinted at the idea that the processes that form comets might be pretty common across the galaxy. However, 2I/Borisov wasn't just a carbon copy of the comets we're used to. It seemed to have a more compact and possibly tougher core. Plus, the amount of carbon monoxide compared to water in 2I/Borisov was much higher than what we usually see in comets from our solar system. These differences raise some interesting questions about what the place where 2I/Borisov came from might be like, and what materials are more common there. Studying 2I/Borisov helped scientists think more about how comets are made and what they can tell us about their home star systems. Even though 2I/Borisov came from far away, it showed us that there might be some universal rules about how comets and possibly other bodies are formed. Every piece of information we gather from visitors like 2I/Borisov adds to our understanding of the universe and how it works. Another intriguing mystery that has caught the attention of astronomers and sparked widespread curiosity is the phenomenon known as fast radio bursts. These are intense bursts of radio waves that last for just a few milliseconds but release as much energy as the sun does in several days. First detected in 2007, fast radio bursts are one of the universe's most perplexing puzzles due to their mysterious origins and unpredictable nature. Fast radio bursts are characterized by their sudden appearance and the vast distances they travel across the universe. They can come from galaxies billions of light-years away, making their journey to us a long and curious one. What makes fast radio bursts particularly intriguing is the variety in their patterns. Some are one-off events, while others repeat, flaring up multiple times from the same location in the sky. Theories about the origin of fast radio bursts are as varied as the bursts themselves. One popular hypothesis suggests that they could be the result of neutron stars colliding or merging. Neutron stars are the dense remnants of massive stars that have exploded in supernovae, and their collisions are thought to be incredibly energetic events that could potentially generate the kind of radio waves observed in fast radio bursts. Another theory proposes that fast radio bursts could be coming from magnetars, a type of neutron star with an extremely powerful magnetic field. Magnetars are known for their explosive outbursts of energy, which could explain the brief, intense nature of fast radio bursts. In fact, in 2020, astronomers detected a fast radio burst from within our own Milky Way galaxy, tracing it back to a known magnetar, lending credence to this theory. There's also speculation that fast radio bursts could be linked to black holes or other exotic space phenomena. Some even suggest that they could be signals from advanced alien civilizations, although this is a more speculative and less widely accepted explanation. Despite the growing number of fast radio burst detections, their origins remain elusive. One of the challenges in studying fast radio bursts is their unpredictability and the difficulty in pinpointing their exact locations in the sky. However, advances in telescope technology and global collaboration among astronomers are improving our ability to detect and analyze these mysterious signals. One specific example of a fast radio burst that has captivated the attention of the scientific community is fast radio burst 121102. Discovered in 2012, what sets fast radio burst 121102 apart from many other fast radio bursts is its repeating nature. Unlike the majority of bursts that flash once and never again, 121102 has been caught sending out bursts multiple times, making it a key focus for researchers trying to crack the code of these cosmic enigmas. The repeating burst from 121,102 allows scientists to study it in more detail compared to one-off fast radio bursts. By observing these repeated signals, astronomers have been able to trace 121102 back to a small dwarf galaxy over 3 billion light-years away. This finding was significant because it provided a concrete location, giving researchers valuable clues about the environment from which these bursts are emanating. The origin of 121,102's bursts has led to various theories. One prevailing idea is that they might be linked to a young neutron star in a highly magnetized environment, which could explain the energy and repetition of the bursts. This theory supports the notion that magnetars, a type of neutron star with extremely powerful magnetic fields, could be a source of FRBs. Studying 121102 sheds light on the nature of repeating fast radio bursts and helps scientists understand the conditions and universal events capable of producing such powerful radio waves. Each burst from 121,102 serves as a puzzle piece, helping to piece together the broader picture of these mysterious signals from space. The study of fast radio bursts offers the potential to solve one of astronomy's most intriguing mysteries and provide valuable insights into the extreme conditions and environments found in the universe. Another one of the most intriguing images captured in outer space that sparked conversations about alien technology is the Pillars of Creation. This iconic image, taken by the Hubble Space Telescope, showcases towering columns of gas and dust within the Eagle Nebula, about 6,500 light-years away from Earth. While not directly thought to be alien technology, the sheer scale and complexity of these structures led to widespread awe and speculation about the wonders of the universe and the possibility of life beyond Earth. The Pillars of Creation are a stunning example of stellar nurseries, where new stars are being born. The image reveals how the intense ultraviolet light from nearby, massive stars is sculpting the nebula's gas and dust into these pillar-like formations. At the top of these pillars, dense regions can be seen, which are thought to be incubators for new stars, possibly even planetary systems. While the image itself doesn't suggest alien technology, the fascination with such a complex and beautifully structured part of the universe fuels the imagination, including thoughts about advanced civilizations and their capabilities. The intricate details and the processes at play in creating such phenomena remind us of the universe's vastness and the potential for conditions conducive to life in other parts of the galaxy. The potential for future discoveries is endless. With advanced telescopes like the James Webb Space Telescope now in operation, and more on the horizon, we're better equipped than ever to spot these interstellar interlopers. Who knows how many more Oumuamuas and Borisovs are out there, waiting for us to catch a glimpse of them. Each one is a messenger from the depths of space, carrying secrets about the universe that we're just beginning to uncover. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable